So what I would like to do is just to bring some of the highlights that come from this big effort we do annually with the Global Carbon Project, which is a big consortium of scientists from all over the world, um, trying to bring together what we call the human perturbation of the carbon budget. That is all the kind of direct emissions from human activity, fossil fuels and industry, land use change, and then the accumulation of that CO2 into the atmosphere, and eventually, of course, the removal of part of that excess CO2 uh, back into the oceans and on land. I'll begin by just actually showing you this figure, which is perhaps kind of unassuming, but yet a very powerful figure showing the last almost 60 years of relentless CO2 from the combustion of fossil fuel emissions and industry growth all the way to 2016. The figure doesn't actually kind of perhaps immediately tells you much, but there's incredible features there that we utilize a lot for really trying to understand what's driving those emissions. And if you kind of notice this, all these little kind of steps where there is slowdowns and even declines of fossil fuel emissions. And the most remarkable thing is that all these slowdowns and even declining, they always coincide with a major regional or global economic crisis or an energy crisis, from the oil crisis in the 70s to the collapse of the Soviet Union in the 90s, to all the way to the global financial crisis in 2007, where we had actually an actual declines. It's really interesting that it's not only until the 2014, 15, 16 that we saw for the first time in the entire record a stabilization of the CO2 emissions. At the same time, the global economy continued to grow. In a way, a little kind of peeking into what it would look like, an acceleration of decarbonization of the energy system that is required for stabilizing climate system. What was behind this remarkable stabilization at the same time with growth in the economy was the fact that coal peaked in the global peak emissions from coal actually peaked in 2013. And soon after, we saw this overall stabilization. We didn't see a decline of the overall emissions because at the same time we have strong growth in CO2 emissions from oil and CO2 emissions from gas. So altogether, they compensated each other, and we had this, what we think was a remarkable stabilization, which many thought that perhaps was the much anticipated global CO2 peak emissions, which is, we know, it's an immediate requirement, to begin the big decline in CO2 emissions required to stabilize the economy. Unfortunately, the data we're presenting this year, 2017, these are projections, is that the overall global fossil fuel emissions will go up again at about 2% per year this 2017. We acknowledge that, of course, there's a big range of uncertainty. The year hasn't changed, and it may not be 2%, but we feel pretty confident that there's no way we're going to go to the end of the year without a significant resuming of the CO2 emission, of the global CO2 emissions growth. Part of the problem has been the simple fact that the global economy has grown much stronger than in the previous years. We had growth of GDP per year of about 2.5%. We move into 2017 with an overall projections to be at 3.6, 3.7%. And I think that what's most concerning in a way is that we don't think that 2018 is going to be much different. The World Bank projections of GDP growth at this point at about 3.8%, which will be, the growth you need to go back to the global financial crisis to see this growth, and it's very unlikely that this growth that we just see coming in 2017 will stop. In fact, will continue if it doesn't get intensified. What you see here is actually this projection are the empty circles for 2017, and then you see the trends in the 60s. For the top major emitters, China, US, European Union, 28 countries, and India. And then the black line represents the 160 plus rest of the countries. It doesn't say much about putting all the countries together. So I'll be focusing on the top 4 emitters. And the reason for the growth in global emissions was largely, not exclusively, but largely because the increase of about 3.5% emissions growth in China. That was responding to an increase of an economic stimulus, which kind of permeated into an increased demand for energy from the industrial sector. Specifically, we saw a lot of growth also in steel production, again, in the construction sector. And most of this energy was really taken up by, or the gap filled with, coal energy. There was also a very unique year in which hydro energy in China was below average because also below average rainfall. All put together, we see a very strong growth, accumulating by the end of this year. US and EU, they're very interesting groups, of course, because for the last 10 years, we've seen a consistent overall trend of declining emissions. It's very remarkable. At the same time, of course, these countries, their economies have continued to grow. But unfortunately, they are contributing a little to this 2017 rise because the improvement or the decline of emissions in the US, about 0.4%, it is actually much smaller than the average for the last 10 years, which was well above 1% consistently. And the same way for EU 28, I think there has been also a little disappointing results because yet it has had a longer term trend in the declining. The previous 3 years, 14, 15, 16, EU had actually quite stable emissions. We're not really going down as per the decadal trend, and I think that this year we'll see again a very small decline of 0.2%, very modest, not exactly what you would be expecting from the top kind of groups inspiring the energy transition. India is a really interesting case. We see a growth of 2% in 2017. It is a very small percentage growth if we compare it to the long-term, well above 6%. We think that it is a one-off coming up from the major economic restructure and demonetization that is going on in India, but nevertheless something to be cheerful about it, if anything. But decisions in the long-term energy choices that India will have incredible impact in the global fossil emissions. Part of the problem of getting this kind of a little acceleration, which is a good thing for countries in the economy, and at the same time just immediately picking up with fossil fuel emissions again, it's kind of represented in this figure where we show the various sectors. Yes, coal is kind of accounts for 40% in 2016 of all the emissions, but I think that we're pretty sure that we really peaked emissions and that we're not going to go back to higher record levels that it was achieved in 2013. However, if you look at the black line, which is the oil emissions, basically for the last 30 years, we've seen nothing but a really clear, a really strong growing trend, which is unclear how this thing may shift any soon in any of the directions other than continuation of increasing. Ultimately, the electrification of transport will actually, of course, have a big dent into these oil emissions, but it's probably decades away to really have a big dent before penetration of electric cars can really happen worldwide. What we also see as well is that it's the non-fuel sectors like the plastic sectors, all the other uses from oil that are the ones with the highest demand for oil products and ultimately emissions, or in the case of plastics, some sinks, but in any case, incredible demand for oil for decades to come. And of course, gas, the blue line, has always gone up. And again, it's unclear we're going to have the immediate substitutes. And when I speak about immediate, I mean over the next decade or two, to be able to really kind of curve down these trend of emissions. So in a way, the problem is kind of well reflected here, and of course we know this thing very well. This is now the energy consumption, global energy consumption. It's not the CO2 emissions, and what it shows is that more than 80% of the whole energy portfolio is coming from the first three columns, which just happen to be, of course, the fossil fuel columns, and that's why with strong increase of GDP this year, strong increase of GDP forecasted for next year, it's hard to think how you can actually not grow emissions along with this economic growth. So I spoke about fossil fuel emissions. I'll have a few words on the land use change component. Land use change accounts for about 12% of all anthropogenic emissions. That's the decadal average. And I think that what's really important is that quite often we could become dismissive about it's a small quantity. We just need to focus on fossil fuels only. It's 12%, which basically means that it is more than 4 billion tons, almost 4 billion tons per year of CO2 emissions into the atmosphere. But this is the net balance of the land use change. So we have what we call the gross fluxes. Gross fluxes will be the flux from deforestation that can be easily at least double the amount. It just happens that some of it gets compensated by a lot of regrowth in abandoned land, either agricultural abandonment or in the tropics also, a lot of the shifting cultivation project of agriculture where land is abandoned. Of course, there's regrowth. But what's important is that these gross fluxes are really critical because these are the gross fluxes that we can manage, that the land use and the management of the land can actually contribute and assess, what's the capacity for contributing to the overall mitigation that is required. I want to show this study, which it's a very recent study. It's not done actually by the Global Carbon Project, but it's very relevant for what I'm actually discussing here. And it was the first assessment globally of pantropics that used LiDAR technology, laser technology, to develop biomass profiles of the land in a continuous biomass density manner. That is, it didn't distinguish anything, whether it's a forest, it's a grass, it's a bushland. It kind of just mapped all across every year for 12 years changes in the in the biomass density of the landscape. And what was really remarkable of this study is the fact that it kind of pointed at whether we were looking at in the right place to look for all these land use change CO2 emissions. It showed that only a third of all emissions coming from, in this case, not emissions, but changes in biomass coming from the tropics were coming from deforestation, only 1/3, and that 2/3 were coming from what we call remaining forests that are harvested, forests that they may be selective logging, forests that by being opened up by forestry, perhaps they lead to some degradation. Then disturbances come in, fires come in, and the collective of management plus disturbances all interacting with each other was responsible for the largest part of the emissions. Quite remarkable. It shows that how little we still know globally, and of course, specifically from the tropics, where the emissions are coming and what's most pressing for us to be managing. So, so far I've spoke about the emissions, and the next is that all these emissions from fossil fuel and land use change, they need to go somewhere. And of course, they either accumulate into the atmosphere, about 46% stays there, or they've been taken up by the vegetation, about 30% on average over the last decade, or they removed or they moved into the ocean, about 24%. It's kind of remarkable to see, if you look at the green patch, which is what the land does to the overall system, and it's this incredible, growth of the scene, but incredible internal variability, which of course is reflected with what's happening in the atmosphere. The ocean also has variability, but perhaps more than internal variability, it has really interesting subdecadal and decadal patterns of variability, which are very important for us for distribution. But altogether, it shows a little the complexity that leads to the example that I want to show here. And that is to show here that there is the blue bars are the atmospheric growth over the last, since 1960, and the arrows are pointing out to the record growth rates in atmospheric CO2 growth, record of the entire period, which coincide with the period when we had no growth in anthropogenic CO2 emissions. And the point here is just a reflection of almost kind of peeking a little into the future as global warming occurs, what El Nino did in 2014-15, which is these two top bars of very rapid and in this case record growth in atmospheric CO2 accumulation, is that the hot temperatures, as Maya just pointed to, above the pre-El Nino global average, push the land sinks specifically to be less effective. And by being less effective, letting more CO2 to accumulate into the atmosphere. And that's what it's reflected here. This is an exercise in progress with global biochemical models of land in this part of this trendy group that we organize. Cable is one of our Australian model is a contributor, and it shows that the net biome productivity, that is how much carbon is accumulated in all these parts of the world, it kind of declined the amount of it. There was a smaller overall uptake of carbon in the tropical regions in many of the quarters of this 2015-16, which included Amazonia, Southern Africa, and Southeast Asia, Australia. And if we take the next step, gross primary productivity is actually like photosynthesis. And what this data is suggesting to us is that when there's these very hot temperatures, what we find is that plants are just able to uptake less carbon dioxide than they would otherwise. And the overall CO2 stays in the more CO2 stays in the atmosphere, more CO2 accumulates into the atmosphere, and we see this rapid growth. In a way, it is peeking a little into the future in the sense that this is the kind of temperatures we're going to have, within a decade or two, an extra 0.2 degrees centigrade to the global average, and notwithstanding that. An El Nino at a 0.2 degree higher temperature may not be exactly the same as an overall steady or more stable temperature warming. It just shows the sensitivity of the land sinks in this particular case, and how under warmer conditions they're less able to remove anthropogenic carbon from the atmosphere. I'll shift here a little gears to kind of move straight into kind of more the specifics of the tracking of the Paris Agreement. The first thing I want to show is again this picture on CO2 emissions, but then a juxtaposition of what we call the carbon intensity of the global economy. That is, how many grams of CO2 we emit per every US dollar of wealth we create. And what's really remarkable is that as emissions have gone up, the carbon intensity of the global economy for the last 60 years has come down very dramatically as well, at 1 to 2% per year. And it is a trend that it has been going on for 100 years. The global economy has always become less carbon intense. And the reason I'm making this point is that this is what we call decarbonization of the global economy. And decarbonization has always taken place. 100 years ago, 200 years. We have always been able to produce more wealth by being more efficient, by switching from coal to gas to oil, from moving from manufacturing to more services. The bottom line is that we have always done better at kind of improving the performance of the carbon intensity. And this is relevant because as we look at the things that we need to do into the future to stabilize the climate, it's very important that this 1 to 2% decline in the carbon intensity needs to actually become much faster, much bigger than the global growth of the economy. If the global growth of the economy is at 3% or 3.6% as this year, and the carbon intensity goes down at a 1 to 2%, it means the result is a net accumulation of CO2 into the atmosphere. So when we talk about we need to decarbonize, what we're really saying that we need to accelerate many times over the speed at which we're decarbonizing the economy, so that we are the decline is many times faster than the actual growth of the global economy. Now, we talk a lot about the carbon budget to climate stabilization, in this case, the 3 trillion ton carbon budget to stabilize the climate well below 2 degrees, and the fact that there's about 800 billion tons of carbon remaining. Of course, these budgets are very uncertain. I mean, truly very uncertain. And whether the 450 to 1,000 gigatons of CO2, it is a fair range or needs to be extended, probably needs to be extended. And what we always say is that, at this pace of 40 billion tons of carbon emitted to the atmosphere every year, well, we have 10 to 30 years left. The reality is that, this is at current emissions of 40 billion tons. It doesn't mean that in this way we could, have a reduction of emissions quickly. And of course, you can extend these 10 to 30 to many more years as you began the decline in CO2 emissions. Now, if we were to take this budget and say, well, let's just kind of articulate how we're going to, move into a trajectory which, we start we're peaking and we're coming down very quickly until we just get to zero, which is what's required for stabilizing the climate, zero net emissions in the end. This is what would you come up with fundamentally. So if you go like at the bottom, the softer curves going down, you would see that pretty quickly you need to be at rates of 3% per year emission reductions. And if you were to say, no, let's just wait another 10 years, you can see how quickly that 3% goes to 10% and how much quicker it goes to 30%. So, rates of decline that make absolutely no sense are pure impossibility. This is just kind of playing with numbers. But it shows a little the concept of the budget, the concept of delaying action, basically taking an emission reductions, and the fact that all these rates are almost an impossibility. And of course, I'm no one for me to say whether this thing is technologically possible or not. But what's important is that the Paris Climate Agreement didn't actually sign on to this figure. It didn't sign on the budget and say, that's what we need to do. Let's sign. We're going to go at 10% mitigation reductions per year. No one would have never done. What what we kind of came up with, not necessarily by designing the Paris Agreement, was to say, all right, there's not enough carbon budget left, so let's overshoot the budget, and then let's kind of repay later on. Let's go into credit, and then let's repay later on by doing what we call the net negative emissions. That is removing carbon dioxide from the atmosphere. There's been a lot of discussions about this, and this is truly what really informed the Paris Agreement. So when negotiators, kind of agreed on the 2 degrees, or there was a proposal for the 2 degrees, I mean, that's what we looked. They looked this, and there's all these integrative assessment models of possible worlds into the future. Maybe not doing much, business as usual, get us very hot, and we just signed into this Paris Agreement. I don't think that anyone realized much at this point, at least from the negotiators' point of view, that most of these scenarios were requiring that during the second part of the century to remove all these amounts of carbon dioxide from the atmosphere, not just to arrive to a point where we're zero net emissions, but really moving into an area where we're actively removing atmospheric CO2. And that's what we really agreed with implicitly in the Paris Agreement. Now, if I take all those Paris Agreement curves, and I put them against what we're doing so far, what we have here is fossil fuel on the top, and all these curves are multiple scenarios that they basically show, where we should be, to be on track to stay below degrees. The various colorful lines are more related to when policy starts, immediately later on. I will not talk much about it. And you could say from fossil fuels that perhaps we're not doing too bad. And then we can move into the solar and wind, and also the black line shows that we're probably not doing not too bad either. And then when we're going to nuclear, we're kind of a little below. And so, yes, a lot of these scenarios, they require, in order to balance the books at the end and not to break the economies, to have some significant amount of nuclear, which will need to grow into the future. And of course, this thing hasn't happened. If anything, nuclear output has declined, since the Fukushima accident. If we go to then carbon capture and storage, again, it's the big, we're totally off track. So many of these scenarios are calling from hundreds to a few thousands of these carbon capture and storage facilities by early 2030s. And at this point, there's barely a handful of these facilities which are in the planning stage, and that they may or may not be in place, within the next decade. So we're completely off track on what the models are saying we should be doing with carbon capture and storage. We're doing quite well with biomass, and we're doing quite well with hydro. So you can actually say, there's a few things we're doing well, with things we're not doing too well, and maybe as a whole, we're not in bad shape. The reality is that the two things we're not doing, and that most of the models are calling for, it's nuclear and CCS, carbon capture and storage. We are the single most capital, intensive development, and I guess that's one of the reasons why this thing hasn't happened. But these also are investments which take many years, multiple decades to really develop the capacity, and certainly by lagging behind, it's completely inconsistent, which could be, being reasonably on track of these 2 degrees. Another way to also look at, so this is like the same kind of figure, we've seen so far, but it's been updated now to what the IPCC is going to be using for its next assessment for 2021, which is called the Shared Socioeconomic Pathways. So there'll be many more runs and models which will do this. This is what's available, a couple of handful scenarios already. And again, plotting against the INDCs for 2030, the national determined contributions, we also see, and of course this thing has been said many times, that those NDCs are not truly on track for a Paris Climate Agreement. And I think that I like the simplicity of looking at it this way because we're not doing here too many assumptions other than the assumptions which are embedded, and they're very diverse with the scenarios themselves, which basically consistently, for most of them, although there are a few out there that they could still reach the 2 degrees with incredible mitigation rates, which probably are unattainable. So look at, I spoke a lot of, kind of the hardness and the difficultiness. The reality is that there's a number of things which are going very well as well, and things which, that show that things are possible. And so we do have 22 countries accounting for 20% of the global emissions, which have now a 10-year trends on emission decline and GDP, going up. And of course, these are mostly the European, Central and Northern European countries and the United States. It's also remarkable to see, and I realize that Germany perhaps is a very interesting case, socially over the last, 40 years, but Germany peaked its fossil fuel emissions almost 40 years ago. That's remarkable from a country which manufacturing was and is still is really important, a country that fossil fuels was and to a large extent also continues to be important, yet they're being able to do a decline of fossil fuel emissions now, as I said, almost for 4 decades, and is still an incredible economic performance in the world stage. Now look, I'll show these figures. Well, this is again energy consumption, globally, and I didn't say anything about the other renewables. We're growing at 14.4% over the last 5 years, and that's largely solar and wind. That's remarkable. This is a doubling time of about 5 years, which means that, in 5 years' time, we'll at 5 and 10 years, we'll be, probably producing, if we continue this momentum, producing almost half of the energy produced by coal. Remarkable at such an accelerating pace, which of course, no one had really predicted in the past. Finally, I'll just to kind of compliment, because I thought maybe people wanted to know what's happening in Australia. So the GCP doesn't, really do any analysis of the nations. The nations do their own analysis. Of course, the OECD nations, more than any others in the world. We do kind of look into the big emitters just to kind of make sense of the global emission changes and global atmospheric changes. But this is straight from the Department of the Environment and Energy. And CO2 emissions, of course, have gone down for a number of years, before 2007, which we don't show here, and then a little of a stabilization, and unfortunately over the last 2.5 years have gone up. That's certainly, as we know, this is exactly the opposite direction we need to go, just to meet the Paris target of 2030, whether it's enough, whether it's big enough or not, that's not the discussion here, but just to meet that target, we would need to be reducing emissions every year by about 1.5 to 1.7, and at this point we're just doing, a bit the opposite. So look, just to finish here, just to kind of say 2 words about what happened in the COP 23, which is finished in Bonn just this Saturday, and the agenda was not big. It was supposed to be mostly a technical agenda. Of course, everyone is expecting big announcement outside of the official role. That's the civil society, the big corporations. Not much really happened, but I do want to, bring a few things. It's hard not to talk about, the Trump factor as not being a fundamental component of COP23. COP23, in a way, the hidden agenda, at some point was just to ensure that momentum kept going after the announcement, the U.S. to pull out of the Paris Agreement, and really avoid, by all means, what could potentially be a stampede of other countries leaving the Paris Agreement, because they saw that one of the big leaders and big polluters were not following through this thing didn't really happen. If anything, now we have every single country in the world signed into the Paris Agreement. So I think it has been not really relevant. It is true, and we don't think that the Trump factor had much to do with the emissions of 2017. If anything, we are actually 100% confident that the decline, the less decline that we saw in the U.S. in emissions was largely coming from the fact that natural gas price went up, and so that immediately opened up a gap in terms of filling cheaper energy sources, which was taken up by majority by renewable energy, but also by a little bit of 0.5% increase in coal energy. That's the first time that coal energy goes up in the U.S. For at least 5 years now. So, I mean, this thing was purely economics. There's no doubt about that. The Trump effect will have, to some extent, an effect, not stopping anything, but certainly perhaps not letting it go as fast as it would go otherwise. The other really important thing in terms of finances, that there was not a lot of big discussions, but again, back to relating it to the U.S., I mean, the U.S. is no doubt about the single most important donor of any major investment in the past, certainly in the climate change space. The fact that the U.S. has made it very clear that, or the government has made it very clear that it will not be contributing to the Green Climate Fund, supposedly to be reaching this 100 billion mark by 2020. We're barely at, a handful of tens of billions of dollars fully, not even annually. So it really kind of leaves a huge gap, which is hard to believe that any other nations or block of nations could really pick up. So I do think that in the finances then, the Trump factor, it is actually important. The other one is a lot of discussion about Chinese leadership and as to whether, China will take, and I think it's more of a media, it's more of a media thing than anything else. China is not taking a major leadership on its own, other than just being part of the official line. I think it's more of a U.S. media issue, but nevertheless very important. China, emissions are going up. We have a big thing to resolve. Coal is still king of energy production in that country, so I'm not sure that China wants to really play much of a role until they have their house in order. Very interesting thing from from a research point of view as well is the fact that something that there was no publicity whatsoever, but there was an agreement, which it's an official agreement now, but as I said, there hasn't been any publicity about it. It was to bring together as a package everything that has to do with climate change, agricultural production, agricultural carbon or greenhouse mitigation, and food security. This is actually the first time ever the convention agrees to bring as a package and to look at as a package the entire climate to food security continuum. In the past, food security has been totally separate from mitigation and from climate impacts, in the sense that food security is untouchable. It's something that no one will compromise one bit. But I think that bringing it together, if anything, will strengthen and will give a much stronger body for working towards possible solutions or possible ways to find win-wins for mitigation and for food security. So the convention is now charging SAPSTA, the technical body, to really bring a number of workshops and technical documents on how to do this, and I think that perhaps there's some opportunities there. And the last one is the global stock taking. That is, the Paris Agreement has asked, basically to really help to the research community, to really help out there on how we're going to just make sense of what the countries are doing and what nature does and what the carbon cycle and greenhouse cycles are doing, and ultimately, the impact of climate, to make sure that we're on track with what we're saying and that things are according to, what the expectations are. So I think there's great opportunities. we begin some analysis. What we're showing here is that we would love to, of course, start utilizing some of the atmospheric records to tell, whether we're seeing any signatures of what potential mitigation could be. And what we show is that if you were to start now declining fossil fuel emissions by 1% per year, which is quite remarkable, you would need to wait about 10 years before you can actually pick up a signature, a signal in the atmosphere. And our effort now as a carbon cycle community is really trying to find the critical research advancements we need to do in order to reduce that 10-year time to a much shorter, hopefully, 5 or less than 5 years, to be able to make a much bigger contribution. I'll just stop here just to say that all these materials, PowerPoints, resources of both the data, the figures, whatever, videos, infographics, everything is just in the Global Carbon project. And also we developed this Global Carbon Atlas, where it's kind of more of a tool, an interface tool for people to dive and kind of interrogate fossil fuel emissions mostly by country, compare, utilize different variables that you want to explore, and so on. So thank you very much for your attention.
Okay, thanks, Pep. Fantastic. I've got a question here, but before I ask that, I just wonder if you could take a quick moment and tell everyone what the relationship is between the Global Carbon Project and the Nest Hub. Why is the Nest Hub, interested in supporting your work, and also what's the connection with the Global Carbon Project and the Hub?
Yes. So the Hub is supporting a project on carbon, and it has two components: a global component and a kind of an Australian component. The Australian component is dominated by the further development of a key tool that is part of ACCESS, the climate model, their system model that CSIRO, the Bureau, and universities are developing. CABLE is the land surface model. So we're kind of working in making that model a little more sophisticated. So when fully plugged into the climate model, can actually tell us things about Australia we're interested, fully coupled. The global is kind of supporting me mostly, my contribution as the executive director of the Global Carbon Project to fulfill, my coordinating role to bring together these global consortiums to be able to bring some of these data sets, these annual analyses that we deliver. It is consistent, in terms of putting data and packaging the data and doing the assessments in a way that brings data on the table, which is relevant for the convention, the technical bodies, but all these things trickle back down to the nations, and that would include Australia, to be able to access all these data to look at how other countries are faring, or what other countries are doing, or how Australian contribution, along with all the other contributions, come together in a global package, which is what ultimately the convention and Australia, as signatories of the Paris Agreement, we need to ensure that everything kind of makes sense and comes in place as we're planning it now.
Thanks, Pep. Now, the question I have for you here has come from Mark Stafford-Smith. He has said, Karen, could we ask Pep what the level of emissions is from oil when it's used for plastics compared to when it's burned as a fuel?
Yeah, so it's a great question, and I have no answer. I'll say it because the reason it's different is because with plastics, what we have is that when we dispose of plastics, whether they end up in the middle of the ocean or properly in a landfill, we're just beginning to develop global data sets to understand, like, to what extent is actually a sink. Well, it's a sink. It's not a sink. It's that the emission never went to the atmosphere. It's just kind of, you take the oil out, and there's just a little, perhaps emissions from the processes, of making the plastic, but then a big chunk of that plastic, goes and stays for, 100 years in a landfill or in the middle of the ocean, I don't know. So I have no answer, but just remember that, of course, it will be a much smaller fraction because this, the fact that the turnaround time for this to end up into the atmosphere is extremely long.
And a follow-up question to that was, what proportion of oil production goes into the plastic industrial cycle?
Yeah, so it'll be small. Look at, I'll drop you an email just to tell you exactly. But it will be a small percentage. It's just that it's growing very quickly as the plastic, and not only plastics, any other non-fuel uses have been growing for the last 20 years, quite dramatically, but still from a low base.
Thank you, Pep. Now I have a question from David Caroli. You talked about the impact of El Nino on the land uptake of carbon dioxide. Is there yet any clear signal of climate change impact on land or ocean uptake of carbon dioxide, apart from the increase in vegetation uptake on land?
Yeah, so our core business for many years, and remains our core business, is to really understand what's driving any potential changes of what we call the urban fraction. You know it very well, the fraction of total emissions that stay in the atmosphere. Actually, Mark Rappert developed this concept of the single rate, which clearly shows that the growth of the sinks, both the ocean and the land, are growing slower than the emissions are growing. So to large extent, this is embedded into the models. The models do eventually say something about an increase in the urban fraction. Whether we're doing it well already for the last 50 years, which is what we study the most, or not, I won't be able to answer well. Now, the issue that we have such big uncertainties, and even more than ever before now in the land sector, it is really giving us a hard time at doing this analysis properly. At this point, if I use different data sets for land use change emissions, I can get a slightly different answers. And the two different answers is that either the urban fraction hasn't changed much over the last 50 years, or the urban fraction is actually growing, which is, we published this thing a number of times, but we're just unhappy with the fact that we're not really constraining better the land use component. I think that some of the satellite new products may go into that direction, but this thing has not yet permeated into the overall global data sets.
Thanks, Pep. I have a question from David Etheridge. The declines of carbon dioxide concentrations under decreases in emissions shown in the last slide, do these include the opposing effect of carbon dioxide flux from the oceans?
I think you'll need to repeat this one.
Yes. So just the question is with regards to the declines of carbon dioxide concentrations under decreases in emissions shown in the last slide. Mm-hmm. Do these include the opposing effect of carbon dioxide flux from the ocean?
Yes, of course. These are, yes. So these are global runs of Earth system runs with, of course, very simplified Earth system or climate system, when this thing is fully part of an integrative assessment model. So the answer is yes, and yes, there is degassing. From, as you go into negative emissions, there's degassing ultimately from the oceans. So the first principles are all in. It doesn't mean that we are not missing any really important points, and we often talk about to what extent the carbon cycle is a symmetric system as we go up with emissions and as we go down with emissions. So I think that it's an incredible area of research for us to really address.